All right, so I just realized my video went out. I'm sorry, my audio went out there at the end of the very end of that last problem. So we'll pick it up here. Use your equation to predict total tuition, room and board for the 2019-2020 school year. So let's just go ahead and write the equation so we remember what it is. 795.07 times the number of years since 2000. So 2019 would have x equal to 19 plus 10,626.63. And when you do this calculation on your calculator, you're going to get 25,732.96 total room, board, and tuition prediction for 2019-2020. Now, how about question number 5? Use your equation to predict the total tuition for 1990. All right, so how many years is 1990 since 2000? That's 10 years before. So we're going to let x equal -10 in this case to predict the cost in 1990. So the cost is going to be 795.07 and x is going to be -10 plus 10,626.63. And when you put this in your calculator, you get the cost 1990 to 1991 tuition, 2,675.93. Oh, for those days again, huh? Question number 6 wants to know, or they're asking us to use our equation to predict what year, in other words, we want to find the value for x, what year the tuition will reach 30,000. So, when will this equation equal 30,000? 10,626.63. So we want to solve for x. So we put our fingers over this. Anything not under our fingers has to go to the other side. So we're going to subtract 10,626.63 from both sides. That's going to leave us 19,373.37. Bring down the 795.07 x, and if we want to get x by itself, divide both sides by 795 and 07 cents. 795, and we get x equals 24.37. So at the beginning of 2024, the tuition is not at 30,000 yet. But by 2025, somewhere between 24 and 25, in the year 2025, the tuition has exceeded 30,000. So we would say the 2025-2026 year is when tuition is going to exceed 30,000. And question 7 asked, what was the correlation coefficient? R was 0.999. R squared was also 0.999. This is a number between 0 and 1. And the closer it is to 1, the better the coefficient, the correlation is. So better, closer to 1. Well, this is very close to 1. 0.999 is very close to 1. So this is actually a very good fit for our data. Let me give you an example. Let's say I wanted to use linear regression for this data model, and we come up with the line of best fit. The calculator would come up with this orange line of best fit, but notice each individual data point is actually pretty far from the line. So the correlation coefficient would not be near as close to 1 for this. I don't know, maybe it might be like 0.7 or 0.6 or maybe even 0.5. That's what the correlation coefficient is telling us. And on our data, almost all of our data points look like they were exactly on our line. So we have a very good fit for a line. Now the last thing is to find the residuals. The residual is the difference between the actual value and what the model predicted. So let's find the residuals for 2002, 2003, and then we'll find the residual for 2008, 2009. And that's the difference between the actual and the model. What was the actual tuition in 2002? $12,014. And what does our model predict if we use our equation and put 2? In other words, basically do this equation, but for the year 2002, 2003, we're going to have a 2 in there. When you put that in your calculator, the model came up with a prediction of 12,216.77. The residual is when you subtract them. So the difference between the actual value and what the model predicted in this case was a negative, which means our model was too high. $202.77. Now if we look at our data and our model for 2008, 2009, what was the actual value and what did our model, or what did our equation predict? The actual was 17,092. And if you put an 8 in our equation, you're going to get 16,987.19. So the residual is the difference. Actual minus the model or the prediction. In this case, it's a positive number, 104.81. Since the residual is positive, that means our prediction was low, was off.